Let's just jump right in, shall we? Welcome to this explainer. I'm so glad you're here because today we're doing something super practical and honestly incredibly satisfying. We're going to take this static, kind of overwhelming visual glossary of 16 different electrical tools, the kind of image you look at and just think, wow, that's a lot, and we're going to transform it. We'll turn it into a step-by-step guide for tackling literally any electrical project. So whether you're a seasoned DIYer or you just kind of want to know what exactly is clanking around in a professional's tool bag, stick around. We're going to decode this whole shebang together.
Okay, taking a look at this image, at first glance, yeah, it's a lot. It's basically an overwhelming grid of 16 totally disconnected items. We've got pliers, testers, tape, these weird-looking levers, and just a whole lot of insulated rubber. It's organized chaos, right? Like if someone handed you this pile of tools, where would you even start? Well, that's exactly the puzzle we're solving today. We're not just going to memorize a boring list. No way. We're taking this chaos and organizing it into a real-world logical ecosystem.
So, to master all this, we're going to break it down into 4 simple stages. Testing and safety first, cutting, stripping, and pliers, making secure connections, and finally, routing, lighting, and finishing. Let's get to it.
All right, kicking things off with phase 1, testing and safety first. So mentally block out the rest of the board for a second and just zero in on items 1, 3, 11, and 16. These 4 tools right here, they are your absolute first line of defense. Before you even think about touching a bare copper wire, before you ever unscrew a wall plate, you have to interface with these guys. They are basically the gatekeepers to keeping you safe, because making sure you don't get shocked is, well, it's the absolute foundation of any electrical work. Literally, everything else is secondary.
You've got to start by protecting yourself physically. And that means grabbing item 16, the electrical insulating gloves. And hey, these aren't your basic gardening gloves, okay? They're specifically built to resist electrical current. Once your hands are safe, you'll grab item 11, the neon test screwdriver. This is a total classic. You use it for basic voltage checks. Basically, when you touch the tip to a live contact, this tiny little neon bulb inside the clear handle lights right up. Actually, fun fact about this, it uses your body's natural capacitance to complete the circuit safely. It instantly tells you, hey, danger is present.
Now, moving on to item 3, the NCVT. This is just a brilliant piece of modern tech. It stands for Non-Contact Voltage Tester, and just like the name says, it lets you detect a live electrical current completely safely without ever physically touching the exposed wire. You literally just bring the tip of this pen-like tool near an outlet or a wire, and if it senses the electromagnetic field of a live current, beep, 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 it flashes red and sounds off. It's an absolute must-have for super rapid, safe diagnostics before you open anything up. But what if you need actual, precise numerical data? Like you need to know the exact voltage or check continuity to make sure a path is complete. That's when you reach for item 1, the DMM, or digital multimeter. See, the neon tester and the NCVT, they tell you if power is there. But the multimeter, it tells you exactly how much power is there. You can think of it as the diagnostic brain of the entire toolkit.
Okay, moving right along to phase 2, cutting, stripping, and pliers. So the power is verified completely off right. Now we can actually start physically manipulating things. We're zeroing in on the heavy lifters of the kit, items 2, 4, 5, and 9. That's your cable cutter, wire stripper, insulated screwdrivers, and pliers. If phase 1 was all about diagnostics, phase 2 is all about muscle and precision. And honestly, using these tools creates such a natural, satisfying workflow. Picture this. You've got a thick piece of wire sticking out of your wall. First, you cut that raw cable to length using item 9, those heavy-duty cable cutters. Next, you need to expose the copper inside, so you grab item 2, the wire strippers. If you look closely, you'll see these precision holes on the jaws. Those are sized perfectly to bite right through the plastic insulation without nicking the delicate copper underneath. Finally, you shape those freshly exposed wires with item 5, the needle nose pliers. They give you the perfect leverage to bend a nice little hook to wrap right around a screw terminal.
And, this brings us to item 4, both the flat and Phillips screwdrivers. Notice how they're entirely encased in that thick red plastic? They're insulated. Because let's be real, using a standard bare metal screwdriver for electrical work is, well, it's a really shocking mistake waiting to happen. Even when you've tested the power and know it's off, these insulated drivers provide that crucial secondary layer of safety while you're driving screws and tightening down terminals.
Which brings us to phase 3, making secure connections. All right, our wires are expertly prepped. Now we're at the climax of the job, making the actual electrical connections. This is where the magic happens, and the circuit is actually formed. Let's look at tools 6, 7, and 13. Now, they look completely different from one another, but they all do the same fundamental thing. They're just different fastener styles for securely bringing your electrical pads together so current can flow without any dangerous resistance or arcing.
And we've got a really cool contrast here between two totally different generations of tech. On one hand, you have item 7, the classic wire nuts. You probably know these twist-on connectors. You hold two wires together and just physically twist this cap over them until the internal spring bites down tight. It's old school, it's cheap, and it works. But on the flip side, check out item 13, the modern lever wire connectors, usually called WAGOs. With these, there's no twisting. You just push the stripped wire right in, snap that orange lever down, and boom. Instant, perfectly secure, highly visible connection. It's a really great example of how these tools are evolving.
Alternatively, let's say your project needs a permanent, mechanically clamped bond, like you'd see in automotive wiring or fixing an appliance. That's when you need item 6. It's a ratcheting crimping tool. It uses a specialized mechanism to squeeze metal connectors onto the wire with just an incredible amount of uniform force. And the cool part? The ratchet actually forces you to squeeze it all the way down to a secure crimp before it'll even release. It literally removes human error from the equation completely.
And finally, phase 4, routing, lighting, and finishing.
Okay, connections are secure, power is ready. But a pro never just walks away at this point, right? We still have to route the work, secure the bundles, and usually navigate some pretty dark spaces. So our final grouping, items 8, 10, 12, 14, and 15, these are for sure the unsung heroes of the toolkit. They aren't testing voltage, they aren't cutting copper, but they keep the job tidy, illuminated, and structurally sound. Without them, your project is honestly just a messy hazard. The reality of electrical work is that you're almost always working in the dark since the breaker's off, and you can't wire what you can't see. That makes item 14, the LED headlamp, and item 15, the LED flashlight, absolutely crucial. Meanwhile, look at item 10, that big orange coil. That's the fish tape. It's the specialized tool designed to push into walls and pull wires cleanly through long hidden stretches of drywall or conduit. It's a lifesaver for routing power from point A to point B without completely tearing your house apart. And to wrap things up, literally, you'll need items 8 and 12. You use item 12, the cable ties or zip ties, to secure your newly routed wire bundles to the framing so everything stays neat and away from moving parts. Then, finally, you protect any sensitive spots, color code your lines, or just add some extra insulation using item 8, good old classic electrical tape. Look at what we've accomplished here. By grouping these tools into these logical stages, we've taken what looked like a random static image of 16 items, and we've built a highly structured start-to-finish workflow. You now know exactly how a pro tackles a problem safely. You test first with the NCVT or multimeter. You prep your cables with strippers and pliers. You secure the circuit with wire nuts or WAGOs, and you finish it all off cleanly with ties and tape. It's just a perfect, logical cycle. So now that we've decoded this entire visual glossary together and seen exactly how these tools bring a project to life, I want to leave you with one final thought. Take a look at your own workspace. We just proved that an electrical toolkit isn't just a box of metal. It's a sequenced, life support system for your home circuitry. If you had to flip a breaker and open up a wall right now, which critical link in that chain is missing from your bag? Keep learning, stay safe out there, and I'll see you in the next explainer.